A classroom has a row of 35 coat hooks. Paulina likes the coats equally spaced, so that there is the same number of empty hooks before the first coat, after the last coat, and between every pair of consecutive coats. There is at least one coat, and at least one empty hook in each gap. How many different numbers of coats can satisfy Paulina's pattern? You can pause here and solve the problem before seeing the solution. Here is one arrangement that works. Say we have 3 coats. Then the coats create 4 gaps. 1 before the first coat, 1 after the last coat, and 2 in between. Each gap has the same number of empty hooks, with 8 empty hooks in every gap. That is 8 times 4, which is 32 empty hooks, plus 3 coats, giving 35 hooks in all. Let C be the number of coats, and G the number of empty hooks in each gap. With C coats there are C plus 1 gaps. So the total number of hooks is C plus G times C plus 1. And that equals 35. Now rearrange. Move the coats over. G times C plus 1 equals 35 minus C. And 35 minus C is the same as 36 minus the quantity C plus 1. Dividing both sides by C plus 1 gives G plus 1 equals 36 divided by C plus 1. So C plus 1 must be a divisor of 36. We need at least one coat. So C plus 1 is at least 2. And we need at least one empty hook per gap. So 36 over C plus 1 is at least 2. Which means C plus 1 is at most 18. The divisors of 36 between 2 and 18 are 2, 3, 4, 6, 9, 12, and 18. Each one gives a valid number of coats. 1, 2, 3, 5, 8, 11, and 17. That is 7 different numbers of coats that satisfy Paulina's pattern. The answer is 7.